Okay, so here we are. We've printed out our images. Hopefully you've made the correction of the mistake I had before, which was this is supposed to be subplot instead of subplots. Now we need to put together we're going to actually build our model now. And to do that, we need to put together some what we call magic numbers, right? Some variables, global variables that we're going to use throughout. And when we do that, we use all uppercases. So we're going to say input shape is going to be equal to none, comma, image. I should run, let me run all my cells while I type this. Image size, comma, image size. So that's the input shape that we're going to be patching in. It's basically the batch height, width, and color channels. And now we're going to do our output shape. And we want our output shape to be equal to the length of our unique dog breeds. So if we remember the discussion of neural networks and how these things learn, remember that the input shape is all of the data we have. So in this case, what are we putting in? We're putting in the height, the width, and the color channels and then the batch size, right, into our model. And out of our model, we just really want one of the 120 neurons to be turned on. Output shape then is 120, right, because that's the number of unique breeds, and we want one of those to come back and say, hey, this is actually your breed that you have here. The model URL we're going to be using, you're going to have to copy this directly, https tfhub.dev/google/imagenet/mobile net underscore v2 underscore 130 underscore 224, and we want classification, and we want 4. Okay, shift enter. That should all be good. Now we're actually going to write our create model function. So def create model. And what do we want our create model function to take? Well, we're going to have it take an input shape, which is going to default to the input shape global variable we just built there, right? We're going to want to take an output shape, which is going to default to the output shape that we just defined there. And then finally, we're going to have this take our model URL, which again, we're going to have a default to the model URL we just defined. Okay, so now what do we want our model to do? Well, first of all, let's go ahead. We're going to say we're going to print our building model with, and we're going to tell it the name of the model URL we're building with. In this case, model URL. And then let's actually build our model. So we'll say model, model is going to equal tf.keras dot sequential. And what are we going to pass into this model? We're going to pass in, did I load TensorFlow Hub in this build? Let's go back and check, because I do need TensorFlow Hub for this to work. I might not have. That's okay if we didn't. We can load it now. So actually, let's go ahead and insert a cell. Oh, okay. Well, that wasn't good. All right, so we're going to do import sys import numpy as np import matplotlib dot pyplot as plt import TensorFlow as tf. Now here we're going to do pip install TensorFlow hub. I believe that's how it's done. So let's make sure this works. We're good there. Make sure the next one works. Okay, I had not installed TensorFlow hub, so it's good that we did that. Now we're going to go ahead and add another one where we say import TensorFlow hub as hub. Beautiful. Okay. Now we know we have TensorFlow hub in there. Let's go back down to the bottom here because we're going to need that here. We're going to say hub dot keras dot lay hub uppercase keras layer. So now we're actually building out the various layers of our model. In this case, we're just going to use model URL. We can pass it that, and that's going to be layer 1. That's going to be our input layer. And then from TensorFlow dot keras dot layers dot dense units. And now here we're going to put basically our output layer, our layer 2. So we want output shape and we're use our activation is going to be equal to the soft max function. And that's basically going to decide when our layers on and when our layers off. When our neurons, I should say, are on and when our neurons are off. That's going to be the determining function for that. Okay, and that actually sets up our model at a very base level. And then we want to compile our model. So we want to still be in our function model dot compile. And we want to say a couple of things. We can compile our model. We want to give it a loss function. In this case, we're going to take one of the loss functions from the TensorFlow library in Keras. Go to the losses library. And you can see there's a bunch, right? We're going to use the categorical cross entropy. Oh, that's the binary cross entropy. We don't want that one. We want the categorical cross entropy. There it is. That's going to be our loss function. Our optimizer, in most cases, you're going to be using Atom for most of these things. Optimizer is going to equal, and we can get the Atom optimizer from the Keras library again. Optimizers, we want Atom. You can always play with other optimizers, but that's the most common. And then we're just going to say what metric do we want to measure by. We're going to go ahead and measure just by accuracy in this case. But we could pass in a number if we wanted to of things to measure by. But we're going to measure by accuracy. Okay. Let's go ahead and close that out. That's our model compiling. Now we'll do model dot build, and we'll pass it the input shape, and we'll have our function return our model, all compiled and built. Let's go ahead and see if we made any mistakes. Nothing spits out initially, so let's go ahead and run this. And let's see if we get out a model that makes some sense by looking at the model summary. Great. Okay, we did not get it. Oh, because I did a dot instead of an underscore. Let's try that again. Okay, good. Another issue. Let's see what it was. I'm reading through to make sure I've got the right link here. So another thing we can do too is we can highlight this, command copy, go ahead and post it in our browser, see if it comes back with the right thing. Does come back with the right thing. So that's good. Let's go ahead and copy the URL and just see if this URL will work better. Command V. So this is using the classification 5. I don't know that it makes a big difference, but I feel like it's worth a try. Okay, what's our issue now? We're still having this issue with our URL, which tells me it might be my connection. Let's go ahead and copy that. Command copy, see if I can. No, you won't let me do that. Let's come back here. URL. Okay, that looks fine. I wonder if this is a problem here. That looks okay. Don't think I've made a mistake there. It looks like it's having trouble going out and getting the model. But it also just seems like a connection issue. Let me see if I wish I could copy this better. Okay, what is it? URL open error. URL open error TF. Actually, let's write TensorFlow, and it's model URL. Let's just see if we get what we get here. TensorFlow hub error. Okay, good. Make sure you've turned on the internet access. Okay, I guess that could be an issue from. I wonder if that's an issue from here. Let's see. Can't imagine it is, but it's worth checking out. Let's type in Jupyter Notebook to Jupyter Notebook. That was a problem with old TensorFlow. Let's see. I think this is with my connection, and probably won't be an error you face. So we're gonna keep going. Run this one more time and just see, and I'll work on what is the error here, why we're having trouble going out and getting this model. Let's assume we've gotten the model. So we're going to go ahead and train our model. But first, let's set an early stopping callback. And an early stopping helps stop our model from overfitting and stop training. And one of the things you might have heard us talk about last time with in class is that our model was going on to hundreds of rounds, even though it wasn't really improving. So let's go ahead. We're going to say early stopping is going to be equal to, we're going to go back to our TensorFlow library, Keras dot callbacks dot early stopping. We're going to monitor the val accuracy. Basically, like if this is not improving in a substantial way, go ahead and we'll put in a patience of 3, which is basically how careful is it going to be in triggering an early stopping. So we'll go ahead and run that. Okay, good. We've got our early stopping. We're going to go ahead now, moving towards our training. Let's go ahead and set our number of epochs. Remember, number of epochs is going to be basically how many times is it going to train on the 1,000 images. So right now we'll go ahead and set that to 100. And let's go ahead and write a model training function. So definition, train model. We're going to do model equals create model. We're going to do model dot fit. We're going to pass it x is equal to our train data. Epochs is equal to our number of epochs. Validation is going to be equal to our val data. Our validation frequency is going to be equal to 1. And the only callbacks we're going to pass in are our early stopping callbacks. And that's passed in like a list. Early stopping. Okay. And then we're going to go ahead and return our model. Now, I am going to go ahead and call this, but it's not going to work. But you should call it and see if it works for you. Ours is not going to work here because we had that issue with our connection, which I will look at. But yeah, same issue. But that's what you should type to go ahead and build your model now. Okay, and that could take a number of epochs. Mine stopped at 8 initially, so that's all you might need. You might need more than that. In our next video, we're going to look at how we make predictions based on our model.